Namaskar and welcome. Z-test. Now we are with a case of Z-test of the difference between two means one-tailed test. Previously we have already discussed one case of Z-test of difference between two means, but that was a very simple case of two-tailed test. Now we are with a case again inspired from the real life, and that is case of one-tailed test. First of all, let's have a reading of the problem or case. It's been always a subject of arguments that those who are active in athletics and sports are taller than those who are not active in the same. It is a general belief that those youngsters or those people who are active in sports and athletics right from their childhood are taller than the other. Some of the professors of statistics in an Indian university decided to check this and test it as a hypothesis. They randomly selected two different samples, each of size 50, of the students of undergraduation courses from among those who participate and those who don't participate in athletic activities. Yes, it is a matter of curiosity, and it should be. The mean height of 50 male students who are regularly participating in athletics found to be 68.2 inches with a standard deviation of 2.5 inches, while 50 male students who are not at all participating in athletics showed a mean height of 67.3 inches with a standard deviation of 2.8 inches. Can the researchers conclude that in this university the male students participating in athletics are taller than the male students who don't participate in athletics if they test the hypothesis at 5% level of significance? Let's have reading of the second paragraph again. The mean height of 50 male students who are regularly participating in athletics found to be 68.2 inches with standard deviation of 2.5 inches. Yes. The first group who participate, those students who participate or regularly participate in athletics or sports, the number of students in the group 50, this is first sample, 50, that is N or N1 because there are two different groups. The mean height found to be 68.2 inches of this group. Yes, so this is sample mean of the first group. So we are going to use the sign x bar or bar x1. And its standard deviation is 2.5. This is standard deviation of first group, so it is taken as S1. While 50 male students who are not at all participating in athletics, not participating, again the number or size is 50, group size. It is not at all necessary to have the two samples of equal size, no. Showed mean height of 67.3 inches. So obviously it is the mean of the second group, so x bar 2, and standard deviation of second group 2.8 inches. Okay. Now what? First of all, why should this be treated as Z test and not T test? Yes, because some may argue that these two are sample standard deviations. Okay, yes, these two are sample standard deviations, but it is always preferable to go for selection of the test on the basis of the sample size instead of the principle standard deviation of the population known or unknown. No, we prefer to use sample size. It is better. I have already discussed it in the lecture Z test number 1. Okay, so I am not going to repeat everything. Since these two samples are of size greater than 29, 30 or more is called large sample. And for large sample with information about mean and standard deviation, or where these where these statistics can be calculated, we should go for Z test. So sample size is the reason we are going to consider this as a case of Z test and not T test. Yes. Obviously, there are two means, so this should be treated as the test of difference between two means. Now, why should we treat this as one-tailed test? Yes. See the last paragraph of the case. Can the researchers conclude that in this university the male students participating in athletics are taller than the male students who don't participate in athletics? Taller than, underline the word, taller than. Okay. Now, first of all, what should be the null hypothesis in this case? Obviously, no difference hypothesis is the null hypothesis. There is no significant difference between the mean heights of these two groups. That means we are denying the argument that the students participating in athletics are taller than the other. We are denying in our null hypothesis. There is no difference between the heights of the two kinds of students. That is our null hypothesis in simple words. But if this null hypothesis is rejected, what should be the alternative conclusion available to us? That is very clear. What is the intention of there is nothing like the difference in height? That is the age-old argument. But the argument, rather another argument is the students participating in athletics and sports are taller than the other. So if there is no difference in height, that null hypothesis is rejected. The alternative conclusion should be the students participating in athletics are taller than the other students. Yes, are taller than. That means the direction after rejecting the null hypothesis is very clear. It is not like that mu1 equals to mu2 and mu1 is not equals to mu2. No, that is not. We are very clear that if two means are not equal, the mean of this group is greater than the mean of this group. This is the reason this must be treated as one-tailed test. I hope in your mind this is very clear. If you need, you can again watch this part of this lecture and try to understand why should we treat this as one-tailed test. Okay, now first of all, these are the information available, and the last wordings are if they test the hypothesis at 5% level of significance. Okay, level of significance equals to 5%. That means alpha equals to 5 by 100 equals to 0.05. Since this is one-tailed test, we should not divide the alpha by 2. Okay. Now, the critical value, since this is one-tailed, critical value of Z will be 5% level of significance and one-tailed test. Column of alpha equals to 0.05. In the table of critical value from the T distribution, the very last row where the degrees of freedom is infinite, yes, 0.05, and it comes to 1.645. 1.645. This is the critical value. And yes, we are going to use the method of comparison between critical value of Z and calculated value of Z, and also p value. I leave it to you now to use the diagram method to arrive at the conclusion. So after studying this problem in this lecture, you can go for the study or practice of the other methods in your notebooks. Critical value 1.645. Now null hypothesis. There is no significant difference in the height of the students of two groups. This is a very easy way of expressing the hypothesis. More proper wordings are the students participating in athletics are not taller students who don't participate. Yes. So HO mu1 equals to mu2. Mu1 is the mean of the first population, mu2 is the mean of the second population. There is no significant difference. Whatever the difference between the means of the two populations is just because of statistical fluctuations or maybe sampling errors, but not because of the difference between these two activities. That kind of interpretation should be there. Null hypothesis. Yes. Now alternative hypothesis. Yes, very clear. The students participating in athletics are taller than the students who don't participate. Yes, please complete the sentence. That means HA or H1 would be mu1, mu2. Yes, the sign will not be not equal to. Yes, no, say two sides are not open in this case to arrive at the alternative conclusion. It is very clear that if the mean height of these two populations are not same, this group is taller than this group. So mu1 greater than mu2. Yes, one-tailed test. Whether the test is one-tailed test or two-tailed test, there will be no difference in the formula to be used for calculation of z value. Yes, z equals to. Now it will be x bar 1 minus x bar 2 minus mu1 minus mu2. Yes, in many reference books, particularly Indian and Asian editions of reference books, this part is not written because this is taken as 0. Yes, and here mu1 minus mu2 is greater than 0. Yes, this kind of conclusion. So this part is always taken as 0 according to the null hypothesis. So in many reference books the author prefer not to write this part. Now it is upon you whether to write or not, because in different universities different teachers follow different reference and textbooks. Divided by under root S1 square, the variance of the first sample, divided by N1 plus S2 square, that is variance of the second sample divided by the size of the second sample. Yes, this is the formula for Z test of difference between two means. Let's substitute the values. X bar 1 is 68.2 minus x bar 2 is 67.3 minus this should be 0 according to the null hypothesis upon under root S1 square. S1 is 2.5, its square is 6.25 divided by sample size 50 plus S2 square is given to be, okay, let's substitute the original values first, then we go for any kind of calculation. It should be like this. Don't bother about the steps for writing. Understanding the solution clearly is our sole purpose. 68.2 minus 67.3 minus 0. Now I am not writing, I am not going to write it. 2.5 square 6.25 divided by 50 plus 2.8 square, that will be 7.84 divided by 50. So it will be something like this. 68.2 minus 67.3 divided by, simplification will be under root 6.25 divided by 50. comes to 0.125 plus 7.84 divided by 50. It comes to 0.157. Okay. So now it will be 68.2 minus 67.3. 68.2 minus 67.3. I know that it is 0.9, but I am not going to take any chance. Okay, 0.125 plus 0.125 plus 0.157. Yeah, I can write directly the final values of the fractions, but many a times, because of the queries raised by some students who are perhaps studying everything first time, they somehow ask me questions about the steps of calculation which I have ignored to write here. So I am preferring to write a few steps here. Okay. Now square root of this, and it comes to 0.53. Yes. So Z is 0.9 divided by 0.53. So it is 1.698. Therefore we can say that Z is 1.7. Okay, keep it 1.689 because we have the critical value with 3 decimal values. So Z calculated, Z critical calculated is 1.698, critical is 1.645. So the calculated value of Z is greater than the critical value, and when the calculated value is greater than the critical value, the null hypothesis is rejected. Yes, we reject the null hypothesis that there is no significant difference between the heights of these two groups. Now, if we have already rejected the null hypothesis, then what should be the conclusion? Yes, alternative hypothesis becomes the conclusion. So conclusion will be the students, and first of all the conclusion is mu1 is greater than mu2. That is, the students participating in college athletics or in athletics, sorry, not college, because this is the case of a whole university, are taller than the students not participating. Yes, please complete the sentence. Yeah. So ultimately it is concluded that the students participating in athletic activities or regularly participating in athletics are taller than the students who don't participate in the athletic or sports activities. Yes. Okay, let's go for finding the p value. Here. The same calculated value of Z is taken as Z score, and that is Z equals to 1.698 normal area. Yes, 1.645, that is 1.6, mean of 1.64 and 1.65, 0.4495 and 0.4505. this is the value of, this is the area between z equals to 0 and z equals to, not 645, 6, 9, 8. I'm very sorry. By mistake, I actually selected the area for critical value. No, not the critical value. For the calculated value, 1.70, and it comes to 0.4554. Yes, area between z equals to 0 and z equals to 1.7. So, P value equals to 0.5 minus this area, 0.4554. Therefore, P value is something like 5000 minus 4554. So it comes to 0.0446. Now let's compare it with alpha. If it is one-tailed test, compare it with alpha. If it is two-tailed test, compare it with alpha by 2. Alpha is 0.05. Yes? Since P value is less than the alpha, hence HO is rejected or HO is not accepted. Instead of rejected, we can use the wordings HO is not accepted also. It is upon you, according to choice of your, choice of you people or your teachers, you may use the wordings. Either HO is rejected or HO is not accepted. And the conclusion is mu1 greater than mu2 or mu1 minus mu2 greater than 0. That means the students participating in athletic activities are taller than the other students. Yes? Okay. Now, so this was Z test of the difference between two means, one-tailed test. Please be very clear at the whether the test is two-tailed test or one-tailed test, because the critical value are different for both kinds of tests for different values of alpha or alpha by 2. So take care at the time of determining the type of test, because if the critical value changes, the conclusion may also change and you may arrive at a wrong conclusion. So please be careful. It is very much important, and I dare to say that in real life most of the cases of testing of hypotheses are one-tailed test. Yes, most of, because in real life most of the time we go for test of hypothesis of an argument with the intention of rejecting it. The old belief, old statistics, old parameters, when we want to challenge them, that means we want to reject them. Now the situation is different, and in real life we can be very much clear that what do we mean by different? Has something increased? Has something decreased? Yes, so I dare to say that in the real life most of the cases are one-tailed test cases. So please try to understand how to determine a case is of one-tailed test or two-tailed test. That's it. Thank you very much.